everyone. Welcome back to the Deep Dive. We know your time is precious, and you're here because you like to get right to the juicy stuff, the really fascinating insights, without having to wade through a ton of technical jargon. And today, we're diving into some truly exciting advancements in AI. We're going to be looking at some work coming out of DeepSeek AI.
Yeah, absolutely. You actually pointed out this research paper to me, DeepSeek-R1, Incentivizing Reasoning Capabilities in LLMs
Yeah.
via Reinforcement Learning. Sounds like, well, kind of complicated, but it's really cool stuff and definitely worth a deep dive.
Yeah, we're talking about AI that can reason, really reason. And it's not just, the hype that we always hear. These are some real fundamental advances in how AI can understand, learn, and solve complex problems.
Right.
So what we're going to do today is take a look at this research paper, pull out those key insights, and really understand what DeepSeek AI is doing and how they're doing it. And they're exploring some really cool and novel training techniques, which we'll dive into. So let's start off. They talk about two main models in this paper, DeepSeek-R1-Zero
Right.
and DeepSeek-R1. So let's start with R1-Zero. What is it? What's so special about it?
The thing that makes DeepSeek-R1-Zero so groundbreaking is that they trained this model using large-scale reinforcement learning. We call that RL, without any supervised fine-tuning to start off with. And that's a really big deal because usually what happens is you train a model on a massive, huge amount of curated data.
Right.
But they basically skip that whole step.
So no initial training on human-prepared examples, just trial and error.
Yeah.
Right, like throwing it into the deep end and saying, okay, learn to swim.
Yeah, and it worked.
So how does it even learn to reason then in that kind of environment?
Well, they use this RL algorithm called Group Relative Policy Optimization, or GRPO. And what makes this really cool is that it doesn't require that separate critic model, which a lot of RL methods use. And that critic model is often just as big as the main model. So GRPO is really computationally efficient. And the way it works is it kind of compares different attempts and solutions without that constant feedback from a teacher.
Okay, so instead of a dedicated evaluator, it's more like a group of students working on the same problem.
Exactly.
And then comparing their approaches to see what sticks.
Yeah.
Got it. So what motivated it? What were the rewards in this learning process?
Well, actually, the reward system for DeepSeek-R1-Zero was really straightforward. They use these accuracy rewards, which means it's rewarded for providing the correct answer.
Okay.
So, in math problems, if I got the final answer correct and it was in a box it was supposed to be, it got rewarded.
Yeah.
For coding challenges like on LeetCode, they used the feedback from the compiler.
Simple, direct, get it right, you get a reward. Makes sense.
Yeah.
What else kind of pushed it along?
Well, they also had what they called format rewards because they didn't just want the model to get the right answer.
Right.
They wanted to show its work. So they gave it a reward for putting its reasoning steps inside these special tags. They used think and think, and that way they could actually see how it was getting to the solution.
Okay, so rewarded for the destination, which is the right answer, but also the journey, showing its reasoning process along the way.
Yeah.
Very cool. Now, you mentioned they didn't use neural reward models, which I found pretty interesting. Why is that?
Yeah, that was a really deliberate choice because they wanted to avoid this thing called reward hacking, which basically means the model could figure out ways to get that reward without actually learning to reason properly. And, having that neural reward model adds complexity and takes up a lot of compute power as well.
Right. So keep the incentives simple and avoid potential shortcuts that don't actually lead to real learning. Makes sense.
Yeah.
So how did the actual training happen? What was that basic interaction like?
It was actually pretty straightforward. So you would have a user ask a question, and then the AI assistant would provide those reasoning steps within the think tags and then give the final answer inside answer tags.
Right.
Simple structure, very clear framework for the model to learn.
So this model just trained purely through RL using those pretty simple rewards. How well did it actually do?
It was pretty amazing, actually. They saw a huge improvement on the AIME 2024 benchmark. That's a really challenging math competition, by the way.
Okay.
And the pass at one score, which means the probability of getting the correct answer on the first try, jumped from 15.6% all the way to 71% during training.
Wow.
Which put it right up there with OpenAI's 010912 model, which is a really strong baseline.
That's a huge jump from barely scratching the surface to competing with, top-tier models just through self-guided learning. It's pretty crazy.
Yeah, and it makes you wonder, do we even need all that curated data? Or is it more about the learning process?
Yeah, exactly. What about other kinds of reasoning challenges? How did it fare there?
So they tested it on other benchmarks, like Math 500, which is a bunch of different math problems, GBQA Diamond, which has graduate-level questions, Live Code Bench for coding, and Code Forces, which is another coding platform. And what they found was that the DeepSeek-R1-Zero, it did really well on the Math 500 and the GPQA Diamond, even better than 010912 on some of those.
Huh.
But it didn't do quite as well on the coding benchmarks.
Interesting. So strong in the more knowledge-intensive reasoning, but maybe had some catching up to do in that procedural, task-oriented stuff. And they mentioned this thing about using majority voting, boosting the performance on Amy even further, right?
Yeah. So when they generated multiple responses, they did like 64 in this case.
Okay.
And then they just took the answer that showed up the most.
Yeah.
The pass at one score actually went up to 86.7%, which is even better than OpenAI's 010912 on that benchmark.
It's like it's learning to double-check its work or consult with, a team of other AIs.
Yeah, exactly, like getting a second opinion.
Right. It's pretty cool.
Yeah.
Now, you mentioned the self-evolution process that they observed. What's that all about?
Well, this is where it gets really interesting because they were watching this model develop without any initial data to influence it.
Right.
Right. So they could actually see how its behavior changed over time.
Right.
And one of the things they noticed was that the model naturally learned to think for longer. Like its response length, the number of tokens it generated, actually grew significantly during training, which is shown in Figure 3.
So it essentially realized that, hey, to solve harder problems, I need to think more, spend more time reasoning.
Exactly.
And it did this on its own. It wasn't programmed to do this.
Well,
that's pretty incredible.
and as it thought for longer, they started seeing all these like more sophisticated reasoning behaviors emerging. Things like reflection, where it would go back and reevaluate its steps.
Wow.
Explore different approaches to find a solution.
Yeah.
All this just from that RL process and the rewards it was getting.
That's amazing. It's teaching itself how to be a better thinker. They also mentioned this aha moment that they observed, which I gotta say I'm really curious about. What happened there?
So this was during training, and they saw an earlier version of DeepSeek-R1-Zero working on this complex math problem. And it started down one path, but then in the middle of his reasoning, it kind of stopped and said, wait. That's an aha moment I can flag here.
No way.
Let's reevaluate this step by step. And then it switched gears and went on to solve the problem. I mean, it literally said aha moment.
Oh my gosh. It recognized it was on the wrong track, adjusted, and then identified it as an aha moment and used that language. That's far beyond just number crunching.
I know.
It's kind of self-aware.
Right. It's incredible. And it really shows you what can happen with RL when you set up the right incentives.
Absolutely. But, of course, no system's perfect.
Yeah.
What were some of the limitations that they encountered with DeepSeek-R1-Zero?
Yeah. So despite all of its amazing reasoning abilities, it did have some issues with readability. Like, the reasoning steps weren't always presented in a clear and easy-to-follow way. And it also had some language mixing problems, switching between different languages within the same response.
So a brilliant but maybe a little messy thinker, which brings us to DeepSeek-R1.
Yeah.
So how did they address those weaknesses and refine things further?
So with DeepSeek-R1, they wanted to take all the good stuff from R1-Zero, that reasoning power, and really improve that readability and language consistency. And the way they did that was by using what they call a cold start approach.
Okay.
Basically, they fine-tuned the base model with a small amount of high-quality human-written chain of thought, COT data, before they did any RL.
So a little bit of initial guidance, like, hey, this is how we communicate clearly and consistently.
Exactly.
And then they let it loose.
Yeah. And this cold start data, it did a couple of really important things. First, it improved readability, like they enforced this specific format. Special token reasoning process, special token summary.
Okay.
Clearly separating those detailed thinking steps from the final answer.
Right.
Secondly, it helped to filter out any responses that had language mixing or bad formatting.
Okay.
And then third, it had the potential to improve performance even further by providing those human examples of really good reasoning.
Okay, that makes a lot of sense. So give it a solid foundation and clear communication before letting it learn through RL.
Yeah.
So what happened after this cold start phase?
So after that, they went into a reasoning-focused RL phase, similar to what they did with DeepSeek-R1-Zero. But this time, they added a language consistency reward to specifically discourage that language mixing.
Okay.
Even if it meant maybe a slightly lower score on just the reasoning tasks. So they combine the accuracy on reasoning problems with this language consistency score to get the final reward.
Okay, so still learning through trial and error and those rewards, but now with a bit more emphasis on communication clarity and sticking to one language. What came next?
Right. So after that, they did something called rejection sampling and supervised fine-tuning. Basically, they used the RL checkpoint to generate new data for supervised learning, including more reasoning data. Some of it was actually evaluated by another AI model, DeepSeek-V3, which acted as a generative reward model to assess the quality of the reasoning.
Oh, wow.
They also added non-reasoning data, like examples of creative writing, factual question answering, things like that.
Okay.
And they drew some of that from the DeepSeek V3's training data as well.
Right.
So they ended up with a huge data set of about 800,000 examples for this fine-tuning stage.
So they took all that reasoning power developed through RL and then really broadened its horizons.
Yeah.
And refined those communication skills.
Exactly.
Through more traditional supervised learning. So what was the final stage of training for DeepSeek-R1?
The final stage was another round of reinforcement learning, but this time it was for all scenarios like a final polish. And the goal here was to align the model with those general human preferences for helpfulness and harmlessness while still improving its reasoning.
Yeah.
So for reasoning data, they still used those rule-based rewards.
Okay.
But for general data, they used reward models. And they actually focused on different aspects for helpfulness and harmlessness.
Okay.
So for helpfulness, they were looking at the quality of that final summary.
Right.
While for harmlessness, they evaluated the entire response, including the reasoning.
So really making sure it's not just intelligent, but also practical and safe to use. That's a pretty multi-stage process.
Yeah, it was quite a journey.
So how did DeepSeek-R1 actually stack up against other leading AI models?
Pretty well, actually.
Good.
On those tough reasoning tasks like the AMY 2024, it was comparable to and even sometimes slightly better than OpenAI's O1-1217.
Okay.
And on Math 500, it was also right up there.
Right.
And then on Code Forces, it actually showed expert-level coding skills, high percentile and strong ELO rating.
So strong performance where it really counts, those logic-heavy areas. What about its more general knowledge and ability to handle everyday tasks? How did it do there?
So on those knowledge-based benchmarks like the MMLU, the MMLU Pro, and the GPQA Diamond, DeepSeek-R1 did really well there too, often outperforming their previous model, DeepSeek V3, and even beating out other closed source models, although it was a little behind O1-1217 on some of those specific tasks.
Got it.
But then it also excelled on tasks that require understanding long pieces of text like frames and in open-ended creative generation. It got high scores on the Alpha-Cable 2.0 and the Arena Hard.
Okay.
They did notice a little bit of a drop in performance on one of the Chinese simple question answering datasets compared to DeepSeek V3, which they think might be because of that safety-focused RL,
Yeah.
being extra careful.
Right. So it's a very capable model that can hold its own against the best across a pretty wide range of tasks.
Absolutely.
Now, they talked about this concept of distillation. What
Yeah.
is that all about?
So distillation is basically transferring the knowledge and skills of a larger, more powerful AI model to a smaller, more efficient one. And they actually managed to distill DeepSeek-R1's reasoning abilities into smaller models based on the Qwen and Llama architectures.
Wow. And why is that so important?
I mean, think about it. You could deploy these models with almost state-of-the-art reasoning on devices with limited computational resources. It makes that advanced AI more accessible to everyone.
Yeah, that's a game changer for sure. How did they accomplish that? Did they put those smaller models through a similar RL training process?
Actually, no. They did it through direct supervised fine-tuning.
Huh.
They used that huge data set of 800,000 examples that they curated during DeepSeek-R1's training and just directly trained those smaller models with it.
No additional RL, just here's everything I've learned, go forth and conquer.
Yeah, basically.
It worked.
It did. It was pretty remarkable.
So did those smaller models actually inherit the reasoning powers of their much larger parent?
The results are actually in Table 5, and they're pretty impressive. So their DeepSeek-R1 Distill Qwen 7b model, which is way smaller than things like GPT-4o, actually beat non-reasoning models like GPT-4o-0513 on several benchmarks.
Okay.
And then their 14 billion parameter model actually did better than the QWQ32b preview across different metrics.
Wow.
And the larger distilled models, the 32 billion and 70 billion parameter ones, they just blew past the OpenAI's O1 Mini on most of the reasoning benchmarks.
It's like taking the expertise of, a top researcher and enabling someone with fewer resources to achieve those same results. That's pretty incredible.
Yeah, and it really shows how effective this distillation technique can be.
Absolutely. Now, I noticed they included a section on unsuccessful attempts. What was the point of that?
Well, I think it's really important for the whole field, to be open about the challenges and what doesn't work, because it helps everyone learn and move forward.
Absolutely. Transparency is key for progress.
Yeah.
So what were some of those approaches that didn't quite pan out?
So one of them was something called a process reward model, or PRM.
Okay.
And the idea was to reward the model for taking steps that looks like they were correct. But it was really hard to define what a correct reasoning step is, especially for those really complex problems.
Yeah, how do you break down something like that?
Exactly. And it was also tough to figure out if those steps were actually correct. And of course, there was always that risk of reward hacking, where the model could figure out how to get rewarded without actually learning.
Yeah.
So they also tried using Monte Carlo tree search, or MCTS, which is worked really well in game-playing AI, like AlphaGo.
Right.
But when they tried to apply it to language models, they ran into scaling issues because the possibilities are just huge.
Right. Language is so much more complex than a game.
Exactly. And then training that value model to guide the search was really difficult, too.
So while those approaches have been successful in other AI areas, they weren't quite the right fit for this specific challenge. And it's always good to understand not just what works, but also what doesn't.
Definitely.
Well, this has been a truly insightful deep dive. For our listeners, I think we've managed to give you that quick but thorough grasp of DeepSeek AI's work on reasoning in AI. We've talked about their novel use of RL, both with and without that initial human data boost, and how they achieved some pretty amazing results. I mean, that spontaneous aha moment with DeepSeek-R1-Zero was mind-blowing. And then those impressive capabilities of DeepSeek-R1, especially its distillation into those smaller models, it just shows how much potential these techniques have.
And, what I find really fascinating is that complex reasoning can just emerge organically from the right RL process, like we saw with DeepSeek-R1-Zero. It wasn't explicitly programmed. It discovered those strategies on its own.
So here's something to think about. If we can achieve that level of reasoning just through RL, what other incredible abilities might emerge in future AI models as we refine these techniques and scale things up even further? What new forms of intelligence are waiting to be discovered just by providing the right incentives and enough computing power?
It's an exciting time to be in AI.
Absolutely.
So much potential.
Thanks for joining us for this deep dive. We'll see you next time.